Hello, friends. This is Frank from Germany. Back from my vacation, I was in Gran Canaria and it was awesome. It was warm, 25 degrees, the water was 22 degrees, and mostly every day we have sunshine. Yeah, I think sometimes boring. Only wake up and you see the sunshine, but okay. What is the point from this video session? No, the first video session was about milling. How can I mill a PCB at home? The second video session was how can I create a solder dispenser at home, and I show you the feature and chili pepper to um, put the solder drops on the PCB. And now we want build a header for first the solder dispenser and second the pick and place header. Also, we want to make a hole for the spindle and a hole for a little USB endoscope camera. Okay, and you know my sentence, don't speak about it, do it, let's go. So here you see the Cambam. Cambam is a great program and I love it. I love it really because you can design your thing in this window, and after all the designs you say, okay, let's go. We create a pocket or a form with a CNC machine. It's a kind of 2.5 CNC toolkit and I like it very much. The problem, uh, Cambam, it's in my opinion a little bit expensive. I don't know. It costs 150 bucks or so. But you can download a demo version. The problem on the demo version is only you can start this program 40 times. Okay, what you can do is you start this program and then you send your computer in a sleep mode without quit this program, and then you can use this every day. But I know if the PC make a reboot or so, then you are not a lucky boy, and yes, you um, has a problem to start this program 40 times. Okay, but in my experience, you need a half year or so to use the 40 times for all. Okay, let's go. I want to show you how we can build this uh, header. What is a header for a CNC machine? Okay, first of all, we need the right material. It must be stable. And I found a very nice material. It sounds debond. And here's it. You see, on the one side, it's a kind of foil and the plastic foil, and you see, maybe you can see this on the bottom, on the top side, it's 1 millimeter aluminium, and between it's a kind of plastic. Why this material? Because it's extremely stable. Normally, they use this for commercial brakes on the streets, yes, or also for traffic signs on the streets. You can't you can't make it broken because it's so stable. It's unbelievable. The other problem is mostly I have here a 4 millimeter only thick. Maybe it's too yes, maybe it's too small. Yeah. On the other side, I use mostly MDF for the first prototype because MDF, it's very cool to mill. You can mill it very fast. It's a kind of wood with some glue. I don't know. I don't have an example here, but I want to show you this in my second video session. Then we mill this together on my CNC machine, and then you can see what I mean with prototype material. The material HTP is not very stable, but you can test the first things very cool, and if it not very good, this test prototype, then put it in a trash and takes a second because it's very cheap. In my building store, not so far from here, maybe 5 minutes, it cost a quadrat meter maybe 10 euros or so. And the quadrat meter, it's big, it's 1 to 1 meter. And you can use this in little, you can cut this in little pieces. I can go to my building store and can say, hey, I need 10 pieces with 20 millimeter, 20 centimeter to 20 centimeter, and they make this, yes? Okay, but for the first time, we need in Cambam, yes, a dimension, yeah? And we make this so, it's very easy. You go here to this little quadrat, take it, and this is our 0 point. You see, it's a 0 point, and I put this here from here to here. No, doesn't work. Okay, draw the rectangle, and now you put it in the first point and then in the second. You can do whatever you like. It's not so important because we want to change this parameters here. It's better. Now you can say, okay, high is 100 millimeter, and I must check this. Wait, I can so, nee, so. How can I move this? So. Okay, you press the middle button from the mouse, and then you can move this view area here. And here he creates this poly rectangle. You can go and say, okay, corner radius, yeah, maybe we say 5 millimeters, and high is 100 millimeters, and width is also 100 millimeters. And you see we have a great rectangle. This is our dimension. Yes, we cut it out, but we cut it out at the last time because we need this. We have here 100 millimeters to 100 millimeters, and now we need the data from our first stepper. No, first of all, we make a hole for the spindle because you must figure out this here will put it on the CNC machine with a triangle. I want to show this later. And I now the holes are 5 millimeters and 20 millimeters distance between these holes. No, we create a circle. You can put this here, and so it's not so important. And then we say, okay, this circle has a diameter of 5 millimeters. It's very small. And now the middle of this quadrat is 50 millimeters, of course. And then we make this on a place 40 millimeters. Now you can push Control M, or no, first you see, and then on the right say transform and move. It's Control M. And now you must put this point in the center, and then you can move this to the right place. This is here. I think I make it a little bit bigger. Enter destination point. We put it here. Okay. Again, Control M. And reference point, put it here. Now you see the center is on the x-axis 40 millimeters and y-axis 90 millimeters. Yes, this is 100, this is 90. Now we can say Control C for copy and Control V for paste. Now we have a second circle. Go ahead here in these parameters and say, okay, X is 60, the second one. You see, it's very easy, yes? So now we have these two holes to put this header on our CNC machine, and now we need a big hole for the spindle because I want to explain. The header get all the things we need to make a PCB in one process. This means we mill, we need a hole for the spindle. We prepare the solder dispenser. We need 4 holes and no 5 holes, 4 holes for the nuts and 1 hole for the shaft. And then we need a second stepper place for the pick and place stepper motor. Also 4 holes and 1 hole for the shaft. And then we need 1 hole for the USB camera. And we need also a hole for, let me think. No, I think this is all. Okay, so let's go. The stepper. I think we start with the solder dispenser. The very important thing is we need, here's the solder dispenser. I show you in the last video session. We need this 4 little M3 holes, and in the middle we need a big hole for the spritzer. So I never remember on this word. Okay, and I have here a caliper. Yes, and here I have the threaded nut, no, the threaded rod, and now we can measure the diameter from this little M3 uh, nut bolt threaded rod, right? So now I make this so 0, and then we measure. It's 2.91 millimeter. 2.9, I want to say. No, 2.88. Okay, then we make a hole with 2.9 millimeters. Okay, we notice. Control V, take a circle. Only here, so, and then we say the diameter is 2.9 millimeter. So, and I can show you the data sheet from this stepper. You see also the distance between these holes is 26 millimeters. Okay, and then we put this in our plan. This circle, Control C, V, and we have a second one. The center is here 24. And we put this, wait, checks again, 26 as far as I remember. 26, 24 plus 26 is 30, 50. So, and now we can select both of them. Wait. Both of them, you see this, and make Control C, Control V. Now we have the second one, and we can say, okay, Y, X is empty because we select 2 of these holes, but Y we can change. 62 plus 26, I think. Oh, I forgot this today. 26, right. 62 plus 26 millimeters. 68, 88. So, and now we have this holes. We can use it. We select the 4 last holes, and now we can move this to the right place with a reference point. It's not so important. And I think I have here some problems with my recording software, but doesn't care. Very important now is we have to know the middle point from this holes, yes, or the center from this construction. You can see here 26, 26, and in the middle of 26 we make a hole for the stepper shaft. The stepper shaft now for the surgery is, is this diameter from this spritze. I want to measure this now. And it's very important you measure this I don't know the right English word. I want to show you a translation word for this. Very genau. Yeah, it's a typical German word. It's very genau. Okay, we have here 18.65, 18.68 millimeter. I guess, okay, 18.68. Okay, now we make a circle. So, and we give the diameter 18.68, I think. Yeah. It's very important that this big hole is in the middle from this construction because we have to know the offset between the axis from the spindle to the axis of this construction. First of all, we put the 4 holes to null. I want to show you this. 4 holes and put this to null. Wait, Control M. And then we put this one here on null. Then we can put the big hole in the middle. We have 26, 26. It's 13. And then we can say, okay, put this to 13 and also 13. And now it's in the middle from this construction. So now we can move this construction to his place. Select all the things. Sometimes you can make a group, but I don't know how, but it's not so important. Control F to move your, and then we put this construction. Yeah, I think maybe so. So now it's very important. We make the hole from the Spindel oder for the Spindel. This I have to measure. Now I want to show only a circle. The data for me, it's I measure this. It's I don't know. I have to measure this on my CNC machine. What I mean is the middle of the spindle, the distance from the middle of the spindle to the construction. Yes. For me, I guess it's 50 millimeters here. And we need a hole, maybe ER off. I can check this. Wait a moment. Now I find it. The clamping nut for ER11 has a diameter of 19 millimeters. And we can say, okay, we take 25 millimeters. Yeah. Okay. 25, we need a hole with a size of 25 millimeters. And this will be in the center here, maybe here. So, and then you can see on the lower right corner, yeah, you can see only the position. And here we have 28 and we make 25 millimeters diameter. Okay, cool. So important is the distance between the middle point from the spindle and the middle point of this stepper. That's a very important measurement. And we put this to, we select this, okay, and then we can say maybe, okay, here we can't. So now we can use the middle point, Control M to move, Control M, and then we make this here in the middle. So, and now we can move this to a value that we can very good use as offset. Yeah? I put this here. Then we have on the, no, we make this here. on the x-axis 20 and from the y-axis also 20. The difference, the distance between this hole and this hole is 1, 2, 3, 4, no, 5, right? 50 millimeters and 30 millimeters. Yes, then we can. It's very cool for us to give this offset chili pepper, and he now okay. On this place is the solder dispenser. Here's the spindle. I can recalculate this, and it's cool. So now we need a second stepper construction, and this is very easy. We select this one, and then we say copy and paste. No, control. You can say also undo, and we select this so. Okay, cool. And then Control C, Control V, and Control M to move reference point, and we put this mirror technique the same center on the other side point, and we have our holes for the pick and place stepper motor. Now we need only um, a hole for a USB camera. I want to build this with a USB camera, but we don't know we make this or not. But we have this hole, and then we can use it, right? I think it's a good idea to make some holes, maybe for 8 millimeters, 9 millimeters or so. So now I found it. This is a little endoscope camera. You see, it's only a kind of pipe, and you can um, make the little LEDs inside a little bit lighter. The quality is it's poor. Yeah, it's not very good quality, but it's very good for our plan to make a pick and place machine. And now I want to show you. No, a little bit. Okay. Now you see you have a kind of yeah, lamp and so on, and in the middle it's I don't know you see this, but in the middle is a little camera. It's nice, but the good thing is it's a pipe, right? And now we can measure the diameter, the outside diameter of this little camera pipe. 0, and then I measure this is 9.73 millimeters. I rotate this a little bit, 9.73 millimeters, and then we say 9.75 millimeters. And we build a circle here, and then we say, okay, you have a diameter of 9.75 millimeters. I want measure this again, 9.75. Yeah, 9.75 is cool. Put this on a border. And very important, this camera needs also an offset. Then we can calculate this later for our chili pepper software. So we move it. No, we can put the moves here, and I think the best place is 20 and no 10 millimeters. We need this on a corner. Maybe we need a screw. 20 like 10 millimeters. Yeah, so. And X, we say, okay, the best way is on the same axis as our big hole for the spindle. This is 60. Right, correct. So now we can do also make some holes for other things to prepare something and so on. But for the first time, I think it's enough. Now we created only some vectors and so on, and now we want to mill this thing. So, and for mill, it's also, I think, very easy. Yes, David, very cool. Now we want to mill the things. For the first time, we mill all little holes. The best way is to select a hole this one, yeah. And then we say, okay, or we select, the best way, we select all the holes, all the circles, cool. And then we say, okay, this one will be a profile. So, and now it's very easy. You say outside, no, we want to mill inside. Um, the name, yeah, we can say holes. So, and then we say the depth increment is 9.4 millimeters. For my prototype in HDF or MDF, you can say, oh, 1 millimeter. Target depth, I know this, I have this in my brain, 10 minus 10.25 millimeters. The cut feed rate is 1000 and the plunge feed rate is also 1000. But okay, we say 800. So this means 800 millimeter in a minute. It's very fast, but we mill MDF and MDF. You can. I have now I have a HF spindle. They can mill with 30,000 rotations per minute, and that's it's easy. The tool diameter is for me 3 millimeters. Double fluid, you can normally, also 3 millimeter diameter, and here you can say, okay, take the 3 millimeter two fluid end mill. That's okay. And this is all. Now he can generate the ways, the generate tool path. You see, now he start here and then he go here and so on. Also, you can see the cut width, and here it's close to possible, but you see here it's impossible. We have to use a tool with a smaller diameter. Okay, then we use 2 millimeters, also very stable, and say here 2 millimeters, and say here generate tool path again. And now you see he make also these little holes. Yeah, very cool. That's all. Now you can say, okay, generate produce G code, and he asked, okay, where I can save this G code, and you can send this to your chili pepper machine, and let's go. It's very cool. So, but we need the outside also. This is a poly rectangle, and this is also a profile for sure. So the second one, and you have to care about the sort of this processes. Yes. Now he mill first the holes, and then he mills the profile because it's logic. If you mill first the profile, then it will not stable on the table, and then yes, you can't mill the holes. I don't know how can I explain this, but you know what I mean. So now it's outside. Yeah, it's correct. Profile name, you always say outside profile. Then increment the same data, 1 millimeter, target depth minus 10.25 millimeters. Cut feed rate is 1000 and plunge feed rate is 800. So, and now it's very important. You can build holding tabs. We can say, okay, make some tabs, automatic, and then he make automatic some tabs. You can also move these tabs. I want to show you this in 1 minute, but the tool diameter is 2 millimeters because I don't want to change the tool. And now we put this here, 2 millimeter and fluid. And when you say generate toolpath, then you can say he make on this places the holding tabs. But the good thing is you can move this holding tabs. you click here and move this to the right places you want. So it's easy as, okay, this is second one here, and then you can change some parameters from this tabs. Yeah, but normally you mill this and then you can use a knife and cut this on at these positions. Okay. Yes, now everything is cool. We can here give a name for this part. We say, okay, this is the solder dispenser header. So, and now you can say, let's go, produce G-code, save this hardware X dispenser, solder dispenser header and C. And Cambam is syncing, and now you get very good G-code. So for the first time, it's enough. The next video session, I want to show you how we mill this physically on my CNC machine. I hope you enjoy this video session, and see you later.